Hi, this is going to be an AP video. We're going to cover a couple problems that are in the section 15.4. So these are similar to some Wabasein questions. I'll post the question number next to the video. But anyways, so here we have a problem where we're going to want to know the pH at the halfway point to the equivalence, which is the pKa, and at the equivalence point. And we're titrating here a base. This is a base with a weak base with a strong acid. So if we were going to look at this, and this would be the added volume of nitric acid, we would have kind of that kind of a curve. So what we're looking for is the pH at the equivalence point. And, if, let's say that volume was 20 mils, then we're looking for the halfway point at 10 mils, the pH, which is the same as pKa there. So for the first part, I'm going to let B equal the base, so I don't have to write this out all the time. And then my reaction is going to be B plus nitric acid, which is, let's just do hydrogen ions. And that's going to give me a weak conjugate acid we'll call BH. So for the halfway point, it's a pretty easy calculation. We would want to use, pH equals pKa plus the log of the base over the log of the acid. But halfway, those are equal. So that becomes 0. So pH is just equal to pKa at the half equivalence point, and that would be the negative log of the Ka. But we don't know the Ka. We've been given the Kb because this is a base. So in order to get Ka, we would want to use 1 times 10 to the negative 14th, the Kw over the Kb. So I end up with 1.79 10 to the negative 11th. So if I take the negative log of that, my pH equals 10.75. The equivalence point's a little bit more involved. So again, at the equivalence point, that's when you're going to have the base and the acid. Those amounts are going to be equal. So in this question, in the beginning, it told me that I have 100 mils of the base and it's 0.1 molar. So I have 10 millimoles of base. So that means that I have the same number of moles of acid because I'm at the equivalence point. So the problem is in this question is that I know the molarity, but I don't know how much of the acid I've used. So I'm going to determine the volume of the nitric acid. And I'm going to do that by plugging into the molarity equation. I'm going to do millimoles. So I know the nitric is 0.20 molar. And I know that at the equivalence point, I have 10 millimoles. So I'm looking for my volume in milliliters. So my volume of nitric acid is 50 milliliters. So now I can figure out my total volume is going to be the 50 mils of nitric that we just calculated plus the 100 mils of the base. And that gives me a total of 150 milliliters. So now I can figure out the hydrogen ion molarity. And I'm going to do that by taking the 10 millimoles that we know we have, because we know those are equal to the base at the equivalence point, divided by the total volume. So the molarity is 0.667. So now I'm ready to do the stoichiometry. So the stoichiometry is going to be the reaction of the base plus the acid makes the conjugate acid. So before the reaction occurs, you're going to have 0.667 molarity of both of these. And you're not going to have any of the weak acid BH present. After the reaction, let me kind of separate some of this. So this was us determining the volume of the acid. And then over here, we're determining the molarity of the hydrogen ions. And now we're doing stoichiometry, and we're looking at the molarity of the hydrogen ion and the base are equal, and those are at the equivalence point are 0.0667 molar. So then after the reaction, these are both going to be consumed. So I'm going to have 0 moles of the base, 0 moles of the hydrogen ion, and then because of stoichiometry, I'm going to have 667 molarity of the conjugate weak acid. So now I know I'm going to have to do an equilibrium problem because I'm trying to determine the pH, and it's not 7 because it's not a strong base and a strong acid. It's a weak base and a strong acid. So we will anticipate that our pH should be lower than 7 when we're done. But now we have an equilibrium problem. So we're going to do a Rice table. So again, I'm going to kind of separate some of this. So above the green line, that was just the stoichiometry. And that, oops, sorry, I moved the green line in the wrong process. I'm going to move it down or not. Let me see. Okay, here. Oops. So the green line should actually go here. And the point of that, we know that we're consuming all of the base and all of the acid, but we do still have a weak acid. So the equilibrium reaction is going to be the weak acid reacts with water, and it's going to produce hydronium and base. And initially, I know this is 0,667, and I'm going to assume that I don't have any of this. So then the change is I'm going to use up the weak acid, and I'm going to produce hydronium and base. So at equilibrium, I have 0,667 minus x, x, and x. So now I'm going to write my Ka expression for that equilibrium. And I'm going to sub in. So in the question, it's a long one, isn't it? They gave me the Kb. So I am going to have to solve for Ka. Did I already do that up above? I swear I did. Yeah, I did. Ka is right here. So it's a long problem. I forgot where I was at. Right here. So we know Ka is 1.79. Let me double check. 10 to the negative 11th. And then these are x. And we're going to assume x is small. So we'll be able to put 0.0667 here. So when I solve for x, that is the hydronium ion. And I get 1.09, 10 to the negative 6. So then the pH at the equivalence point is the negative log of that. And that is going to be 5.96, which makes sense. If you're titrating a weak base with a strong acid, the pH is less than 7.